Section 1.3 Arithmetic Sequences. Our objectives are to identify and graph arithmetic sequence, find a common difference, write an arithmetic sequence recursively and explicitly, use summation notation, and find the nth term and the nth partial sum of the arithmetic sequence. We might not get to those last two, but we'll kind of see how the video goes. So an arithmetic sequence or an arithmetic progression is a sequence of numbers in which the difference between each term and the preceding term is always constant. This constant is called the common difference. You can find the common difference, d, by subtracting any two consecutive terms. So, for example, we have the following sequences given below. We want to figure out if they're arithmetic or arithmetic, same thing. So, if so, what's the common difference between the term and the term preceding it? Now, in order to do this, you have to make sure you check all of your terms to make sure that they all have the same common difference. So, if I'm looking here, if I look from 14 to 10, I notice that I have a common difference of -4. If I subtract 4 from 14, I get 10. And if I subtract 4 from 10, I get 6. And if I keep going, all of these I am subtracting 4 to get the next term. So that means, yes, this is arithmetic sequence, and the common difference, d, is -4. So then for the next one, we do the same thing. So if I look from this term to this term, I know that the difference would be 2 that I'm adding. But if I look from 5 to 8, notice the difference now is 3, and 8 to 12, the difference is 4, and 12 to 17, the difference is 5. So because of that, I'm not adding the same number, so I don't have a common difference, so this is not an arithmetic sequence. And then going to the next one, so same thing. Is this an arithmetic sequence? 2 minus, or how do we go from 2 to 6? I have to add 3, or 4. And if I keep adding 4 each time, I get the next term. So that means that yes, this is an arithmetic sequence, and the common difference is adding 4, so +4. So let's talk about the different forms that we have. So remember, we've already talked about recursive form. Recursive form for an arithmetic sequence consists of two parts. Remember, we talked about an initial condition that tells us where the sequence starts, and a recursion equation that tells us how any term in the sequence is related to the preceding term. So the formula that we use is right here. So I'm going to write it a little bit bigger. So our first term, we always have to state what that is, and then a formula to get to the nth term. So u to the n minus 1 plus d. And for this, remember, if we're starting off with u sub 1, that means our values of n have to be greater than or equal to 2. So this is the formula that I'm using. And remember, we said for a recursive formula, in order to get the 100th term, I would have to figure out all the terms that come before that. So that's what makes recursive formulas a little bit harder to use if you want to figure out a term that's very high. The next formula that we have is explicit form. So explicit form of an arithmetic sequence, sometimes you can find the value of a term of a sequence without knowing the term preceding it. Instead, you can use the number of the term to calculate its value. A formula that expresses the nth term in terms of n is called, again, an explicit formula, because if you wanted to find the 20th term, then you should be able to plug 20 into your equation for n and then figure out what it is. So the formula we use, which is right here, I'm going to write it a little bigger. So u sub n is equal to your first term plus n minus 1 times your common difference, d. So in order to do this problem, you have to know what your first term is, just like the last one, and you have to know what your common difference is. And for this one, instead of starting off with n values being greater than or equal to 2, we're starting off with values greater than or equal to 1, because we're saying that our starting term, or it's your first term, is u sub 1. So since it's u sub 1, that's why n has to be greater than or equal to 1. Sometimes we have a different formula that we use for this. If the initial term of a sequence is denoted as u sub 0, then instead of using the formula above, we actually use this form right here. And instead of n being greater than or equal to 1, n would be greater or equal to 0, because I would be able to plug 0 into the equation and find out what your first term is equal to. We don't really use this formula as much, so you do need to have the other two forms memorized. All right, so for example, given the sequence, we want to write a recursive and explicit formula for both of them. The first thing I want to do is figure out what my common difference is for the equation to do that. So if I look here, I notice that between each of these terms, my common difference would be a value of -3 because I'm subtracting 3 each time. I always like to state my first term as well. So my first term is 23, and my common difference is -3. So now with that, I can write my two formulas. So my recursive form, you state your first term, which we said was 23, and then the formula for getting to the nth term. So again, the formula, remember, is always your previous term, so u sub n minus 1 plus your common difference d, and since we're starting off with u sub 1, our n values have to be greater than or equal to 2. So this would be my recursive formula. And then my explicit formula, for this one, we just have to use the formula that we just wrote above. So I'm going to write it again here just to see it. So u sub n is equal to my first term plus n minus 1 times my common difference d. So in this case, my first term is 23. So u sub n equals 23 plus n minus 1 times the common difference, which is -3. I'm going to go ahead and distribute this to each of my terms. So u sub n is equal to 23 minus 3n plus 3, combine like terms, and u sub n is equal to 26 minus 3n. And because we started off with the first term being u sub 1, that means that my n values have to be greater than or equal to 1. So I should be able to plug 1 into this equation. If I plug 1 into this equation, I should get my first term. So let's just check that really quickly. So u sub 1 would be equal to 26 minus 3 times 1. So 26 minus 3 is actually equal to 23, so it checks out because it gave us our first term. So the nice thing about this formula is that if I wanted to figure out the 20th term, all I would have to do is plug 20 into the formula and solve, unlike my recursive form where I'd have to find all the terms that come before 20. So let's look at the next example. For the next one, it says we want to find the nth term of an arithmetic sequence with the first term -5 and a common difference of 3. So I know my first term is equal to -5 and my common difference is equal to 3. So in this time it just gave us that instead of actually giving us the sequence notation. So I would maybe pause it and see if you can write the two equations and then unpause it and we'll look at them together. So for recursive form, again, you have to state your first term, which in this case is -5, and a formula for getting to the nth term using the previous term. So again, remember the formula is your, oh, and I didn't realize above, I meant to put D right here. I actually wrote the general formula, so this should have been minus u sub n minus 1 minus 3. So down here, my previous term, so u n minus 1, and then my common difference is now +3, so plus 3 would be my new formula for n values greater than or equal to 2. Over here for explicit, u sub n is equal to my first term, which we said was -5, plus n minus 1 times the common difference, which is now +3. So my formula, if I simplify, I end up with u sub n being equal to -8 plus 3n, or if you wanted to write 3n minus 8, that would be fine too. And since we're starting off with the first term of 1, n has to be greater than or equal to a value of 1. Okay, so now we're going to get a little bit of harder examples. It says, what is the 45th term of the arithmetic sequence whose first three terms are 5, 9, and 13? So the first thing I'm going to do is go ahead and write that down. Now for this, I want to go ahead and figure out what my first term is, which we know. So So my first term is 5, and then I also need to know my common difference in order to write my formulas. So my common difference in this case to go from 5 to 9 and 9 to 13 is equal to 4. So I always need those two things to write my formulas. So let's go ahead and practice both the recursive and the explicit form. So for this recursive form would be my first term and a formula to get to the nth term. So u sub n minus 1, so my previous term, and I'm adding 4 each time for values of n greater than or equal to 2. And then my explicit would be u sub n is equal to my first term plus n minus 1 times my common difference, which is 4. So I'm just going to simplify. So I get u sub n is equal to 1 plus 4n or 4n plus 1, and of course for this your n values have to be greater than or equal to 1. Now if I want to figure out the 45th term, again it wouldn't really make sense to use my recursive formula just to show you. If I do u sub 45 here, I would get u to the 45th minus 1 plus 4, which is u sub 45 is equal to u sub 44 plus 4, but I don't know this term unless I find all the terms before it, so this wouldn't really help me in order to solve, so instead I would always use my explicit form. So if I want to find my 45th term, I'm going to do u sub 45 and plug it into the equation. So when I do this, all I have to do is go ahead and evaluate. So 4 times 45 plus 1 means that my 45th term is equal to a value of 181. And that would be my answer. So let's go ahead and do another example. So for this next example, it says u sub n is an arithmetic sequence, and we know that the 6th term is 57, the 10th term is 93. We have to find the first term and write a recursive and explicit formula for the nth term. So this one's a little bit different because we don't have the sequence and we don't know what our first term is, so we have to find it. So what I like to think about is, I know that my 6th term is 57. So that's my 6th, this would be 7, 8, 9. My 10th term would be right here, which is a value of 93. So the way to think about this is, remember, arithmetic sequence is a common difference. So this is my 6th term and this is my 10th term. So the best way to find what your common difference would be to subtract your numerator over subtracting the number of terms that you have. So my common difference is going to be 93 minus 57 over 10 minus 6. And then I could figure out from this that my common difference would be a value of 9. So the next part I need to do is find my first term. There's a couple different ways you can do this. You could just take 57 and subtract it 6 times and figure out what your first term is. That's fine. Or you can plug it into the formula if you wanted to figure out what your first term is. So I'm going to go ahead and do that way just to show you. So if I know my 6th term, u sub 6 would be equal to, and I'm going to use my explicit formula to help me out do this. So it would be equal to your first term plus, and then n minus 1 times your common difference, which we found was equal to 9. So if I do this, u sub 6 is equal to my first term plus, and then right here we're going to use an n value of 6 minus 1 plus 9. So u sub 6, remember, we already know what that's equal to. So u sub 6 is really equal to 57. And now we have 6 minus 1, which gives us a value of 5, and 5 times 9 is 45. And then all I have to do is subtract. And then we get u sub 1 equals to a value of 12. So now that I know my first term and I know my common difference, I can write my two equations. So my recursive form would be my first term, which we just found to be 12, and the formula for my nth term, so my previous term plus my common difference for values of n greater than or equal to 2. And my explicit form would be my n term. To get to that, we need to know our first term, which is 12, plus n minus 1 times my common difference, which is 9. And then, of course, I'm just going to go ahead and simplify this. So when I simplify, I ended up with, distribute this and combine the like terms, 9n plus 3 for values of n greater than or equal to 1. So this would be my explicit form. Let's see. So why don't you guys do this next problem and we will go over it in class. So it's kind of like the last problem that we just did. Okay, so the next thing we're going to talk about is summation notation. The Greek letter sigma is often used in mathematics to express a series of its sum in abbreviated form. So for example, if we have this notation right here, that means that we want to find the sum of the sequence for the formula being c sub k for a k value starting at 1 all the way up to m. So that means that you would be adding the sum of it together. So if you did 1 into k, you would find c sub 1. If you plug 2 in, you would get c sub 2, and you would just keep adding them all together. So for example, if I wanted the sum of the k squared from values from 1 to 100, what I'm going to be doing then is I'm going to take all those values and plug them into my formula, which is k squared, all the way up to 100 and add those numbers together. So I would do 1 squared plus 2 squared plus 3 squared and so on all the way up to 100 squared, and I have to figure out what that's equal to. So let's go ahead and do these two examples. We want to compute each sum. So for this first one, this is the formula, and again, this is where I'm starting at n values equal to 1 in my formula, and this is the number that tells me how to end. And since I have the sigma notation, that means I'm going to be adding all the answers together. So for the first one, I would have negative 7 plus 3 times 1. That would be my first answer. And then my second one, now that I plugged 1 in, I need to plug in 2. So negative 7 plus 3 times negative 2 would be the next one, plus negative 7 plus 3 times, now I have, I didn't mean to do negative 2 there, positive 2 times 3, and then plus negative 7 plus 3 times 4, plus negative 7 plus 3 times 5. And now I know to stop because I've gone from an n value of 1 all the way up to n value of 5, and I'm going to be adding those answers together. So if I add all this together in my calculator, I end up with a value of 10. So that means the sum of this formula would be equal to a value of 10 when you add up all the numbers together. So let's go ahead and do B. So for B, I'm going to do the same thing. So I'm starting off with n values of 1, and I'm ending with n values of 4. So I'm going to plug those in and add all those solutions together. So my first one would be negative 3 plus n, which is, in this case, we're going to start off with an n value of 1, minus 1 times 4, plus negative 3, and then now I'm going to plug in 2 for n, and then I'm going to plug in 3 for n, and then I'm going to plug in 4 for n, and now that I've gone to the fourth term, I can stop. So if I add all that together, I get a value of 12. So now this would take a lot of work if you had to go up to something that was higher than 5 or 4. Like let's say you had to go up to 100. So we usually don't actually write all this out. There's a way that you can do it in your calculator, which I'm going to show you. So in order to do this in your calculator, you want to go ahead and get that out. So we're going to write this out first, and then we'll actually do it in our calculator. So in your calculator, you're going to hit second and stat, and then you're going to right arrow over to math and number 5, which is the sum So it looks like this with the parentheses. And then you're going to right arrow over to options and number 5, which is sequence. And again, we'll do this in just a second. So the way that you write it in your calculator is you put the sum and then sequence, and then you put the equation, comma, the variable, comma, your begin value, comma, the ending value. So for example, for the first one that we did, I would do the sum. So this is example A, the sum of the sequence. And then I would plug in -7 plus 3n, comma, n, comma, 1, comma, 5, and then enter. So let's go ahead and plug this into our calculators. So it doesn't matter if you're in sequence mode or if you're in function mode. If you're in sequence mode, your variable is going to be n. If you're in function mode, it'll be x. So either it doesn't matter. So go to second stat, and then right arrow over to math. And notice that number 5 is our sum, so I'm going to hit 5. And then go to second stat again. And the middle column, see it says sequence right here, so number 5 again. So now I have sum, parentheses, sequence, parentheses. Then you put in your equation, so -7, and then plus 3x or n, whatever mode you're in, comma. So the comma is right above the 7. Your variable, which I'm using x, so comma. And then my starting was I started with n values of 1, and I went all the way to n values of 5. And if I have 2 parentheses in the beginning, I need 2 to close, and enter, and notice that I ended up with 10 for my solution. Now the cool thing about this, if I hit second, enter again, instead of doing the sum of the sequence, if I actually just wanted to write the sequence numbers out for each of those, 1 through values 1 through 5, if I take away this sum right there, I'm going to delete this other ending parentheses and I hit enter, notice that that gives me my first 5 terms. So my first term is -4, my second term would be -1, my third term is 2, and then 5 and 8. So what your calculator did for you is it added all these together. So -4 plus -1 plus 2 plus 5 plus 8 gives us a value of 10. So we're going to go ahead and stop here, and we are going to do the rest of this in class and kind of do some of these problems together. So if you wanted to, you could do this example right here. It says use the calculator to display the first 8 terms of the sequence and to compute the sum. So I just showed how to do that. So either you can do it and then we'll go over it again in class, or you can just leave it blank. It's up to you.